So for the introduction of this assignment, electrical machines such as DC and AC motor generators are widely used in industrial, commercial, and utility applications due to the operation at high voltage, current, and mechanical speed. These machines can cause serious safety, legal, and environmental risks if not properly designed, installed, operated, or maintained. Therefore, we must follow and comply to international and national safety standards such as IEEE, IEC 60034, OSHA, and the National Electrical Code (NEC). It is essential to ensure safe operations, legal compliance, and sustainable performance of electrical machines. This presentation discusses key safety and legal standards, regional compliance requirements, practical application of these standards in real-world installations, and reflect on the ethical responsibility of engineers to protect workers, the public, and the environment.
Assalamualaikum. My name is Muhammad Arash bin Abdullah. My name is number B1103241039 Okay, about objective this assignment. The central goal of the assignment is demonstrate a comprehensive understanding of how electrical machine standard translate into real world compliance and safety practice. Specifically, we will cover first standard research, summarize key international and national standard including IEEE, IEC 60034, OSHA and NEC, detailing their purpose and relevance to machine operation. Next, uh, about compliance, explain the necessary regional legal requirement protocol and certification for machine operation, focus on lockout, out, lotto, grounding and insulation. Lastly, application scenario describe a hypothetical engineering scenario to insulate the step-by-step process an engineer must follow to ensure a new machine installation is fully compliant. Okay, about the key national and national standard for electrical machine safety. Okay, the first one is IEE Institute of Electrical and Electronic Engineer. IEE standard provide a framework for the safety and reliability of electrical power system and equipment design. They they help in managing hazard like arc flash and power quality issues. For example, IEE 1584 for arc flash hazard analysis, and another one is IEEE C57 series for safe and efficient operation of transformer. So the next one, IEE 60034 series for rotating electrical machine. The series of international standard define performance, efficient and testing requirement for rotating electrical machine like motor and generator. For example, IEC 60034-1 specific rating and performance, and another one is IEC 600345 cover degree of protection provided by include IP code. So the next one is OSHA, is a Competition Safety and Health Administration. OSHA standard are US regulation that mandate a safe working environment to protect employees from electrical hazards such as shock, electrocution, and fire. So example, lockout or top up lotto, the energizing equipment before maintenance. So the finally is NEC, is National Electrical Code. The NEC is a widely adopted set of standard in the US for the safe installation of electrical wiring and equipment to safeguard person and property from fire and other hazard arising from the use of electricity. So the example, grounding and bonding. An insulating metal box, pipe, and equipment are connected to the earth via grounding electrode and grounding conductor for safety.
Hi, I want to talk about requirement for practical electrical machine. First, we got the primary legal framework. For example, the electricity supply Act 1919 and Electricity Regulation 1994, which is they are the primary legal framework used to govern the industry in Malaysia. They focus on consent and the legal power. Second, we got the Safety and Health Act, which is OSHA. There are primary legislation in Malaysia designed to ensure safety, health and welfare at all persons. Third, we got the Malaysia Standard MS and IEC, which is this is a main reference that determine the quality and safety of a product or installation. Next, we got the safety protocol. First, we got the permit to work. When someone to work must have a permit. Example, permit number, permit discharge of work or allocation. Next, we must follow the safety installation MS IEC 60364 to protect the electrical wiring. Next, we got the PPE compliant, which is electrical insulating glove, insulating tool, and flame resistant coat. Next, we got the environment regulation, which is we must comply with the Environmental Quality Act EQA 1974, which is to prevent, control, and eliminate pollution to protect the environment. Second, we have MEPS, which is a Minimum Energy Performance Standard. This is a regulatory tool used by the Malaysian government to ensure that ethical appliances sold in the market with a specific level of energy efficiency. And last, we go to certification requirement for compliance. In Malaysia, ensuring operating electrical machine is legal and safe involves obtaining specific certification and a regulation mandated by Energy Conservation Suruhanjaya Tenaga and a SIRIM certification. And also for the largest industry, electrical machine or entire factory must itself be registered under the certification of registration of installation. Next, we're going to talk about safety requirement for machine, DC and AC. First, we got the logout and tagout. This is a safety procedure to ensure the electrical machine and completely turn off and cannot be turned back on during maintenance or repair work. This procedure must be turned off the all my supply and ensure all from the energy are released and place a tag lotto tag with the name that and purpose at the machine. Second, we got the grounding. This is a process of connecting the metal part of electrical equipment to earth so that dangerous electrical current can flow safely to the ground. This method to protect the human and the machine from the leakage current and electrical short. And the wiring grounding must follow the MSIEC 60364. And the last is a insulation standard. This is a standard that specifies the level of electrical insulation to insulate live part from the human or mental structure so that electrical short, leakage current, or short circuit do not occur.
Hello, my name is Muhammad Faris Fahmi bin Arman, matrix number B1124103994, and I will be talking about this assignment application of standards. Electrical safety standards and legal requirements must be applied in real engineering situations. Engineers are responsible for ensuring that electrical machine installations comply with safety, legal, and environmental regulations. This section demonstrates how international standards and Malaysian regulations are applied during the installations and operation of an electrical machine. So let's put it in this hypothetical scenario. The first one is an engineer is assigned to install a new three-phase AC induction motor for an industrial water pump system. So the installation is located in a manufacturing plant in Malaysia. So what the engineer needs to do is and make sure is it need to be comply with the IEC 60034 um, rules for motor design and performance, NEC principles for wiring and grounding, Occupational Safety and Health Act 1994 OSHA, and Suruhanjaya Tenaga ST and DOSH regulations. And the reason they need to make sure that these installation comply with all these regulations is to make sure that they cover part of the worker safety, legal compliance, reliable and energy efficient operation during the installation. So in this slide we'll be talking about the application of standards, the compliance steps, meaning that all of this step could be used by the engineer or the person in charge to make sure to prevent from any accident from happen. So the first step is the planning and design step. Select model compliant with IEC 60034 and verify energy efficiency and insulation class. The second step is to seek legal approval and certification. Ensure equipment is ST approved. Installation performed by ST registered competent personnel, meaning that people who install the motor should be equipped with the right certificate from ST, which is Suranjaya Tenaga. And then the next step is the installation step. Follow proper wiring and grounding practices. Install protection devices such as circuit breakers and fuses. The next step is to follow safety protocols. Apply lockout, tag out during installation and maintenance, and provide PPE and safety signage. PPEs meaning personal protective equipment. So the next step is the testing and commissioning steps. So conduct installation resistance and grounding tests. Ensure emergency stop functions properly. And the last step is operation and maintenance step. So the engineer or person in charge should schedule regular inspections and preventive maintenance. Uh, and they need to also to make sure that it comply with the DOSH and environmental regulation. DOSH is Department of Occupational Safety and Health.
Hello, good afternoon, everyone. Let me have a quick introduction about myself. I'm Praveen from BLR1/2. My metric number is B1124106001. So, right now, I'm gonna do a quick presentation about my slide right now. So, I'm gonna talk about reflection. So, for me, the first point that I get is like standardization as a first global language. So, what I'm trying to tell you by that is standard like IEC 60034 and IEEE are created universal in rulebook for manufacturers and engineers. So, by this, we can ensure that mission built by one country can safely operate in others. So, in this way, what is the benefit of it is like it can really reduce the risk of the failure due to the design or like due to the installations about the missions. So the second point I'm going to talk is legal complaint as a moral and a professional duty. So let me just have like a quick recap about that. So complaints with OSHA and the NEC is not just about avoiding fines. So it's like more about protecting human life. So and then legal requirement for organization is implant regards safety protocols such as lockout or tag out. So it's like LOTC, which prevents machine accidents due to someone working or something will happen by accident. So right now, the third point that I have is like could the critical role of grounding and solution. So the specific safety requirement for DC and AC machines highlight that grounding, and insulation are the primary defense against the electric shock. Okay, by understanding this standard, allow the engineer design the system that safely differs failure current rather than allowing them to pass through to a person and avoid like a accident or death to someone. So right now I'm going to continue with my section reflection. So let me start with it. Integration loss of standard form of insertions to operate. So what I'm trying to tell with my point right now is like safety is not just like a one-time checking up things in of like any kind of project. So it's like application sections like must be integrated every phase from the wiring to the routine of operation safety check to cycle approach to ensure the remaining safety purpose of the machines. So I will say it's really good to have like frequent checkout based on the machine and the age of the machines. So second is like high magnifications of hypothesis scenario. So for example, like think through a scenario hypothesis installations. Scenario prepares an engineer of a real world, somewhat like us. So unpredictably, it impairs the needs for the systematic checklist. It's for verify the machine is like in a good terms to run and to the move to the next forward. So inspection of protective housing and ensure all of the environmental regulations are really ensured to be used during the sections. So my last point will be break, bringing theory and practical. So let me just go through with my points. So moving from researching standards to a hypothesis scenario reflects to the transitions from academic knowledge to industrial components. It shows that knowing the name of a standard is less important than knowing how to apply it rules to physics machines on a factory floor. So it's not just about how good you are in practical. We will suggest you guys to be good in academic wise so you can be really upgrade yourself in any industry. So that's all from me. Thank you so much.